So this is Classic Workshop. This shop is 3 years old. I'm the owner of the shop. Um, this is a second career for me. So I'm an engineer. I worked 20 years in the automotive industry in research and development, mostly for Mercedes, for a couple other companies as well, doing software testing. So I ran teams of test engineers for Mercedes. So a lot of Mercedes that you may have owned or seen on the road from about 2003 to about 2019 or so. I've worked on the interior electronics. However, during that time and even before in college, I've owned old Mercedes and been playing with old Mercedes, and I've probably owned well over 100 of them. Not for profit, definitely for loss, but for education. And I love the cars. And it became clear over time that I knew the cars better than most. And I started working on other people's cars at home because people asked me, and this is probably starting in 2016, 17. And, time went on and more people kept calling me, and I started getting cars from people that are well known in the business that do restorations because they couldn't find anybody else to work on their cars. So suddenly I have, two 280 SLs at home and all this stuff that I'm working on. And my career kind of after 20 years stagnated, let's say. There's no room for real growth without moving out of New Jersey, which I didn't want to do. Had opportunities to move to California, which is where my team went from Mercedes when Mercedes closed in Montvale. Opportunities to move to Michigan, even potentially Germany, but I didn't want to move. So, with lack of real potential, development of my career, I was working more and more on cars. And at some point, I looked at my wait list and I said, it's going to take me 10 years to get through this list. Working in the evenings and working slowly on these cars like I did. I just worked at home when I had free time. So I started looking into opening a shop. Took 2 years to set up the shop here, find the space. And we hit the shop with, hit the ground running with a 2 to 3 month wait list. And we pretty much still have a 2 to 3 month wait list now, 3 years later. So there's no shortage of, demand for service on old Mercedes, which is great. The hobby is alive and well. The cars are loved. The values of the cars, as you all know, is going up. When we look at the last 10, 20 years, which makes repair and proper repair more palatable to owners. Consider myself very lucky to be in this position. So we're 3 years into this business. I have a wonderful staff. So there's 6 of us in total. 2 of my technicians are here today. So Veronica started from the beginning with me. So she's an old Mercedes enthusiast. She trained to be a technician, and she's been with us since day one. And then Bill joined us 2 years ago. So Bill has 47 years of experience
only
in European car.
49 this year.
49.
The tires too.
Yes.
The tires, yes.
And European car tire suspension and so on. So a tremendous wealth of knowledge, as far more than I do about a lot of the suspension. So he'll join in some of the conversation and answer questions. Yep, that's a brief introduction. In terms of what we've got on display here, we tried to set up cars, some cars that we're just in the middle of working on and we couldn't get off the lift, and some cars that I think are representative of the evolution of the rear axle from Mercedes. So this, of course, is out of a 190 SL. This is out of Paul's 190 SL here. There's no rear axle in this car. We have a 220S Ponton that we're restoring on the end, the blue car. That car has a completely rebuilt rear axle, and it looks similar to what this will look like when it's done. And that's in the car, so we can take a look at that and see how it mounts and where all the rubber bushings go and how the assembly looks, not covered in dirt and grease and so on. So it's a good representation. And then in terms of kind of the evolution, we have this is a 108, and then we have a Pagoda a 280SL over there, which is a similar design in the rear axle, but then there's been quite a few changes, improvements, I guess you could say, through that development. And then we put this 300 on the lift, just to give some perspective of where things came from. So this is a 1953 300. Some of them call them 300K. This is the first 300. That's my but it's a car that was restored by its original owner, well, I shouldn't say original owner. It was restored by its owner who bought the car in 1961. And he never completed the car. He got the car to like 95% done. And his family ended up selling the estate. So I bought the car and we finished the car. Maybe I used the term finish a little too aggressively because it's not quite roadworthy yet. But we did go through and make the car run and drive. So unfortunately, the car has a bad main bearing. The engine has a bad main bearing, which I discovered about 50 miles into driving. So,
But it makes sense. Is that the gas on the local?
the gas, yeah, that's the gas filler. Yep. Yeah. So, yeah. Before we got the car, we won't go too deep into that, but I'm happy to answer questions about it. But the car sat for probably 15 years from the last time it was worked on. So it needed quite a bit to get back on the road. For example, I replaced all the brakes. We talked about brakes. The 30-year-old brakes only having 100 miles. These had 0 miles on them. And I still replaced all the brakes because, cars with single circuit brakes you generally want to trust them. So, the car got completely new brakes, for example. So these are the cars we have, as part of this, we'll go through and talk about everything going on here. But then, we can float around, can ask questions about the various cars and various parts. Feel free to interrupt me. I want to make this kind of a conversation. I don't have a PowerPoint set up here or slides. We're just going to kind of maybe take this in an organic way and whatever interests you, we can focus more on. And I don't want to get too technical unless you want me to get too technical. We can see. But yeah, we'll kind of just feel it out. So
what was the problem with Paul's rear axle?
made noise. So it howled or whined, and which is a fairly common issue.
Made noise in the sense of that something is out of whack in terms of bearing.
But yeah, a gear or a bearing.
And was it, Jamie, on Excel or D7?
What was it, Paul? I drove the car in the fall. I can't remember anymore.
It was a whine. If you were at higher speed, it was a whine, and I always referred to it as it sounded like an old truck trying to get up a hill.
Yeah. Like it.
It's I would say howl is probably a good description.
So we took it down. We stripped it down. Paul sourced a new ring and pinion gear to reduce the axle ratio slightly. So this is a 3.7, I think, which I believe was optional in a 190SL. Was also used in diesels.
So when you took it apart, what did you find?
That's a good question. We found nothing that's like a smoking gun. It wasn't like, oh, this bearing is shredded, or it wasn't. No, all the old parts are here. This pinion bearing has some harshness to it. You're welcome to feel it. There is wear on the ring and pinion. There is wear on some of the edges of the races. It's. I was mentioning to someone before. It's possible that this axle had a broken boot 15 years into the life of the car, and someone drove it for 5 or 10 years with a broken boot.
Wasn't that eventually an issue with the rubber axle boot getting a hole or a crack and the lubricant seeping and leaking out?
Yeah.
And that might cause a howl, and I just would keep making sure that I filled it up.
Yes. So it's interesting. We get a lot of these cars in here, and a surprising number of them come in with very little oil in the rear axle. And, and I tell people, when we service the car, if we're going to fill the rear axle, we have to see how long it takes to leak out. And if you have a drip once every day or two, and it's just a little bit wet, and then it's fine. But some of them leave a puddle after a day, and you have to do something. We're talking about this rubber boot here. Where is it? Here. So this rubber boot this is the axle that goes on the right side of the car. The rubber boot fits on here, and then that connects the differential housing on this side, and the pivot point is here, and a shaft that goes through here. So in order for the suspension to move, you have to have this boot that connects the left and right sides of the axle. Now the entire axle is full of oil, so it's full of oil up to this point where there's seals on both sides. So oil can leak out of the boots, and oil can leak out of the seals here. Sometimes you see oil kind of dripping down the backing plates or inside the brakes, or just kind of even dripping inside the wheel. And the failure is related to seals here. So there's a lot of places for oil to leak. In general, the axles are very robust. So even cars that come in with almost no oil in them, they don't make noise very often. I think if they get dirt in them, or they're driven for a really long time, it's different.
When you say a really long time, meaning a trip of extended duration?
Perhaps when it gets hot, or maybe just 5 to 10 years of operation. These cars aren't driven tens of thousands of miles a year, as some, maybe not 190 SLs, but in general, cars could have been, back when they were newer. So I think they just don't experience a lot of wear, even with a broken boot. I think the design is such that you still end up with a little bit of oil in the bottom here, and it seems to be just enough to save the components off it. So
when you add oil, where do you add it?
So there's a fill here,
Okay.
and then so this is how the axle sits in the car, and then on the bottom there's a drain. So the oil level should be just up to the fill point of the fill. So the oil sits, kind of at this level. So everything.
So when it starts coming out, you're full.
Yes, when it comes out, you're full. And it takes about these, I guess, are about if it's completely dry, it's 2.5 liters or something like that. It's quite a bit of oil.
And what type of oil do you use?
Standard gear oil. So I use it. It's a GL5 gear oil. It's a high-point gear oil. You don't really need anything that special. I used to use more synthetic lubricants. I kind of stopped because I'm not sure it really matters. I think these are pretty robust, and I think that standard gear oil, changing the oil, even once every 10 years is great. It's probably more often than most people do it. I think it's out of it. So it works well. Yeah. So, yeah, we can talk a little bit about what this looks like in the car, perhaps, before we get into the gears, if you like. So we have a lot of components here. It's interesting because I think you think of the rear axle as being fairly simple compared to the front axle. But when we lay the whole thing out, you realize there's a lot of components to the rear suspension. So in terms of rubber parts, there's a lot more rubber in the front in the rear rather than there is in the front. The front is kingpins, brass bushings, steel pins and caps, which form most of the joints. There's rubber seals, but the rubber is not actually often insulating the components from each other. But the rear axle is quite different. So we have trailing arms, which kind of runs forward and backward with rubber pieces on each end. These are common failure points. I think often you see these rear trailing arm bushings distort and can cause knocking noises. I found replacement bushings are not as good as the originals. Often cars that have original bushings, if they're intact, they're straight, they're not heavily cracked, they don't change them.
Let's say they're not as good because they're more too flexible.
Yeah, I think they're softer. We have that problem in this car too. The bushings tend to get distorted, moves out of shape. I had that problem. My Ponton, it's a green Ponton. That's my car, which I drive quite a bit. I rebuilt the rear axle because the boot was broken. And after 5,000 miles, the bushing started to screw. So how they're assembled, you have to be careful. You can't use lubricants on these, otherwise they tend to go out of place. But it's interesting that not always new bushings are not always a good thing. These bushings are a little different. The ones that go in the front, they're easy to change. They're very inexpensive. I think this price may still be $20 for Mercedes.
So Jamie, for example, the rubber motor mounts on our cars tend to dry rot.
Yes.
Do these dry rot as well, the original ones, or?
They do, but they're not under quite as much stress.
I see. Okay.
Absolutely. So we have those rubber mounts, and then there's a couple other interesting mounts. So this is kind of an odd-looking contraption. This is actually what holds the rear axle up into the body of the car. So this fits here. Okay. And there's a pin. It also creates the pivot. So if we look at it from this axle, it actually fits here. That creates the pivot. This creates the pivot point. And the axle is suspended in the body from that pivot. So there's two rubber bushings. This rubber bushing, these are all still available from Mercedes. Does a lot of the work of actually supporting the rear axle. It can be difficult to change. There's a metal sleeve inside. And sometimes, often, the metal sleeve corrodes to this pin, which makes removal quite difficult.
Is that original or a replacement?
This is a brand new part.
Okay.
And this is one of the cases where the brand new part from Mercedes really looks identical to the old part, which for a long time was common, but now is getting less and less common. Motor mounts have a slightly different appearance, and the molds have aged, and they've redesigned the molds. This part still looks like that. This one is from Mercedes. It's also one of the rare Mercedes parts that doesn't have a Mercedes star on it.
Does it have the number on it?
No, it doesn't have a number on it either. It's a kind of odd thing. It does have it says Fahrtrichtung here, which is driving direction, so it tells you which way to put it in, because it's not symmetrical. Actually, it only goes in one way. So this is an important bushing. Sometimes these get completely collapsed and destroyed. So these rubber pieces really have to be changed. The support of the other end of this support, I should say, that goes through the pin, is connected with this rubber bushing, and this can fail. The rubber bushing inside can deteriorate and create a lot of noise in extreme cases, but also create a lot of instability in the rear axle. So this is a common wear point as well.
Maybe just so that sleeve when it goes into shaft there. Just out of curiosity, is it idiot proof? Does it have a notch so you can't screw it up? I know you've got the direction.
This one or this one? Oh, this one is pretty idiot proof. Yes, this one.
Okay.
This one just goes right in. It can be a little difficult to get in, but once you get it in high enough, the threads come up through the floor of the trunk and you can screw it. So there's a little locking tab that goes over it. The challenge with this is that the trunk, the back of the trunk in a lot of cars starts to come up where the mount fits. So when you first open the trunk and you look and you say, oh, it's right there. But you realize it's actually very tight to get in there, and it's hard to get tools in there. I think this is what, like a 27 or a 32 millimeter nut. And you can't put a socket on it, so you have to put an open-ended wrench on it. And
Usually it's a several-man job too to get it done.
yes, and you end up with this awkward situation where you have the axle kind of just swinging in the car, suspended by this thing because it won't let go. So these are the kind of things that we encounter in the jobs where sometimes something takes 5 minutes and sometimes it takes 3 hours. So this is
no provision in the trunk to put like a bar in and push down on that pusher.
Right.
So you get no leverage.
there's nothing to find.
You've got to put a washer in there and a lock tab and then the nut.
Wow.
And sometimes it doesn't want to go through the rubber.
I'm just getting that now.
When you assemble that, do you use anti-seize or anything on that?
Yeah, a little bit of oil or anti-seize is a good idea. But it's funny if you see. Yeah.
Yes.
Well, this is
If there was a little something
this is seating
on it, just as long.
just about completely, but I would have to knock this on to go all the way. So even by hand, it doesn't want to go on. So It can be challenging.
And what we're looking at here, this is what you're
Yes.
cut inside there, right?
Yeah, the new part is pressed in here. Yep. So, and this has a careful specification. This has to be installed exactly 90 degrees from the left-hand axle, which is done with the pins. And there are several bushings and spacers and compensating washers. And there's washers that have slots in them for grease to go through. So you have to align, I don't know, 15 or 20 different components at once to get this lined up. And then you have to make sure that this is straight 90 degrees. So usually we do it in a way that we kind of block up the axle to try to hold it in one place. And it takes more than one person. There's bushings here that ride against the pin. I should have brought the pin out, but you can see there's grooves in the bushings here, and there are zerk fittings here. So these have to be greased, much like the front end. And there has to be a specific specified clearance between the pin and these bushings. These bushings can be replaced. And then there are compensating washers that come in various sizes to make sure that the entire stack up is correct, because you need a certain amount of clearance for grease to go through and for it not to bind, but not so much. Otherwise, the axle can move independently of each side. So it's a complicated process to set up. In terms of what else we're looking at here, there's a rod which holds the axle centered in the body of the car. So this sits here, and then this rod sits here and attaches to the body with these two large bushings.
Is that rod adjustable?
It is adjustable, yes. And it is challenging to adjust, but
So it's attaching to the frame.
it's attaching to the floor of
To the floor of the truck.
Yep.
Of the truck. Okay.
So, Bill, you mentioned the little function of this.
Well, in most cases, when you're working on a car where you don't take it apart that fully, it's very easy to put it back in. The difficult thing, and to be honest with you, I've not done it yet, is when we do it on time, when we get it on the ground and aligning it, is getting the axle centered. And of course, there's some special Mercedes tool which we cannot find.
Yeah, the book is full of Mercedes tools, which we can't find. Well, we'll talk about that also when we get to the internals of the differential.
So we're going to have kind of play with that a little.
Does that affect tracking of the vehicle, and also does that affect the tracking of
Yes,
the
it will
vehicle?
affect the track.
So do you find yourself at times creating the specified tool, or does it not?
No, we try and find ways to work around.
Okay.
So, a lot of these tools, I would say, unfortunately, with the 50s cars, most of the tools I've never seen. Yeah, I have all these eBay saved searches, and I scour the internet, and I ask people, and nobody's ever seen them. There's a couple guys that have a few things, but there's a lot of very rare tools for these cars, and they're just not out there anymore. So we have to improvise, and we have to do our best.
And Benz doesn't recreate these tools either.
No. There's no market.
There's no market.
But part of the problem was originally half the dealers didn't spend the money on them when the cars were new, so they never bought the tools.
Right.
So they aren't around now in the used market.
Yeah, and how many people?
A lot of them weren't needed.
Right. At the time, no.
Some were, but some were not.
Exactly.
They had a tool to do everything.
So bring out your jig to hold the entire axle, which
Yeah.
is this part number.
It's amazing. There's a list of special tools that and it goes pretty far back. I'm building an engine for the 170 that's in the corner right now. And it's the section of building the engine starts with a list of special tools. There's like 25 special tools, and I don't have any of them, and I don't even know what they look like. It's a basic description. And as it turns out, you don't need most of them. You have to understand what the tool is achieving,
But its function.
right? And then try to work around and say, okay, well, I'm trying to measure this. What's my reference point, or how can I do that in a different way? And that's those are the problems.
I think the other problem is you know, in the 50s and early 60s, Mercedes was distributed by Studebaker. And all the service was done at Studebaker. And then what happened in 64, Studebaker went belly up and everything shut down. And I'm sure if all of the special tools, if they were sending some Studebaker dealership, it just got lost with the rest.
It's true. Half of it may have been gone.
And it just rears us all out, doesn't it?
Yeah, if they have it, yeah, it's true. Yeah, we find there's a clear difference in the condition and maintenance of cars post Studebaker that we see through here. Like if you see cars from 65 and up, you can find very original, well-maintained cars. Like you can find a 280 SL. What is car? Yeah. I mean, it's just a very well-maintained car that we find cars with original plug wires. We find all kinds of original hose clamps, original hoses, all kinds of interesting stuff. But to find that in a Ponton or 190 SL or even early Fintel cars is very, very difficult. And I think it's because in the early years of service, the dealers just didn't have the knowledge, they didn't have the parts, and they did what they had to do. They had generic American hose clamps, and that's what they used, and you just don't find the original stuff anymore because they were Studebaker dealers that were repairing Studebakers that also had to fix a Mercedes. So they're not going to go and, oh, we got to use the German hose clamp on this one. Just going to go grab the hose clamp and put it on, and that's why you see so many cars with really old standard hoses instead of metric hoses and ignition parts that don't make any sense. And, rigged wiring and wiring changes that don't make any sense, that maybe made sense from a perspective of what these guys were doing at that time. But I think that, they were probably pretty poorly equipped to do a lot of work. I don't think, I think you had places like Manhattan, you had the bigger dealers that were really well equipped, and you had guys that came from Germany, really took it very seriously. But I think a lot of these small mom and pop dealers just couldn't handle it. That's the wind, by the way. Sorry,
The door slamming, you think they help?
maybe, I don't know. You can correct it. I think it's going to keep flowing through the seal. So yeah, special tools are a problem, challenge, and I'm constantly looking for them. We have quite a few, and we have I can show you. We have a few cabinets full of special tools from Mercedes, but not always the ones we need.
So the removal, the repair, replacement of parts that needed to be replaced, and then reinstallation into the Paul's car. How long is all that essentially going to take, ballpark?
So a lot of it depends on how long this takes. But I think we may be into this. I should have totaled this up. Maybe 20 to 25 hours.
Oh, okay.
Yeah. Sorry, Paul. And it took longer because I asked Paul, I said, do you want this to look like we did something or not look like we did something? And, depending on the car and the customer, that's a valid question because some very original cars we fix and we don't want it to look like we were ever there. We want to maintain the original appearance of everything.
But now you've repainted some of these parts, right?
We've repainted and refinished everything, which requires more disassembly,
Right.
more cleaning, and then refinishing. And we send them to our paint guy who does a great job putting this really tough coating, which I think resembles the original pretty closely. And then, additional assembly to put it all back together. For an example, I think this rod is a great example. We had to completely disassemble this in order to properly refinish it. And if we didn't have to do that, we may have retained its settings and its position and not modified it, and it would have made it easier to put back together because we already had a baseline to start with. So we weren't able to do that. So, but I think this is a great way to go. I mean, it looks outstanding, and it's nicer to be able to clean everything. And working with dirty parts on a component like this, where cleanliness is so critical, can be challenging. So even if a part is clean, if it's rusty and it still creates some kind of residual dirt that are on your hands when you're handling it. So when it's freshly painted like this, it's certainly nicer to work. So what else do we have here? We have these axles. So these axles, obviously, this end is where the wheels mount. These axles go through the axle tubes completely and then engage on either side of the so they're solid axles that go straight through. Now, if you notice, the axle tube left side of the car is one with one pivot. So the axle and the differential actually stay stationary from each other, so they don't move. On the other side, on the right side of the car, because of the position of the pivot, we need a universal joint, and we have the length between the differential and the wheel changing. It's going in and out. So you have this joint, which goes into the right side axle housing, and this joint inside has a slip joint. So there's a joint in here that slides, and it's on is it 29 rollers? I can't remember. There's a specified number of how many little rollers have to be in there. And if you lose one, you have to throw the whole thing away and get a new one. That's what it tells you. So you can't lose a single piece. You can't interchange because they wear into each other. So if you lose it, you start over. These are very robust, except in 6.3s. It's the same part in a 6.3. These break in 6.3. So if you have a 6.3 that's really well tuned, like one of these cars with the 6.3 liter engine, and you turn all the way one way and you floor it, you can break this. You're never going to do that in 190s, even if Bob Platts modifies it. You're not going to make enough power. But this is a really interesting part, and it's a complicated part. But it's what makes the joint to this axle possible. And because the position of this axle changes relative to the axle tube, the wheel bearing on this side actually has an outer race that can move. So this is a pretty unique bearing. I don't know if there's too many other applications for bearings like this. It's still available from Mercedes, not available in the aftermarket. But that's why you see on this side, you see the bearing is slightly different than the bearing here. This is a more traditional wheel bearing.
Did you have to replace these, or are these the original?
No, we replaced them. So in order to change the seals on the backing plate, you have to remove the bearing. So you can't change leaking seals without removing the bearing. So you have to disassemble this whole assembly, removing the nut, pressing off the bearing, then you can replace the seals, and then you press it all back together. So if you're getting to the point of removing a bearing like this, you just replace it. Especially these are fairly inexpensive. That bearing, I think, is $150 from Mercedes, give or take, something like that.
Really?
So it's I don't know, it's more expensive than it used to be, but it's not too terrible.
Something more low on one side or the other for these two bearings, like where? Left or the right?
What do you think, Bill? Is there more load on one side, one bearing than the other, left or right, or are they similar?
Probably not.
Probably not. Okay.
No, that's what I was bringing down.
This turns in the house. That
Right.
tube is moving in the house.
Right, exactly.
So that
Yeah.
side, it's not moving in the housing. This side, it's going to be
Right.
pivoting.
Makes
there.
sense.
It's going to go up to
So by this
that's why
differential exists, is this with this shaft in the universal joint here? I think.
Yeah.
And the bearings on the inside.
Yeah.
Again, this one side being fixed.
Yep.
This is the give and take.
Yeah.
How much play is actually how much is it moving, or what's the normal
The range of
of travel? Yeah.
So I think when the
I mean,
axle is horizontal, it's not very much on normal roads.
Okay.
But it does have. I guess that's about
So
an
at
inch and a half
when you're
movement. Quite a
cornering,
bit. Yeah.
all right. So what are we talking? A few centimeters, or I
Well,
mean,
the full
'cause that's
range
a
of-
huge.
Yeah, the full range of motion is looks like about an inch and a half, let's say.
If you look at the size of the gear between the two axles,
Yeah.
you can see that that right side axle's got a lot more gear on it.
Yeah.
Simply for that reason.
So it
Okay.
is quite a bit of movement.
Okay.
Because again, the pivot point is here, not here.
Right.
And it makes a difference.
So that's, I don't know, roughly 4 inches there.
It's what,
The-
3 or 4 times the size of the left axle.
Yeah.
Learn something.
Yep. And you can see the wear marks even. This
Yep.
one
Yep.
has consistent wear marks that end because it really stays stationary in the gear set. But the wear marks, actually, we can look here, are the entire length of the spline.
The wire being there, that shouldn't be sliding on that spline though, because that's sliding and sliding sleeve.
Right. It should
So
slide
that
in
really
line
shouldn't be
completely.
moving at all.
So later cars have a snap ring here that actually holds this inside of that slip joint. But in theory, it could move independently. I don't think it will because the friction between the sleeve and this shaft is much greater than the sleeve inside the bearing.
If you have a snap ring here, how do you pull this out to to the seals without tearing the whole thing apart?
Big slide hammer. Yeah. It's just a metal snap ring, so it can expand and contract. So the idea is that you just, well, to put it back in, actually, like for example, in these cars, if you remove the right axle and the axle has the snap ring, you have to remove the springs on both sides and raise both sides up of the axle completely so the axle will engage into the slip joint. So it actually adds a lot more time to the job because you have to disassemble the left side in order to do the right side. Yeah. And we do a fair number of them. And very often the right side is the side that leaks or has a bad bearing because it just moves more. You know, there's more potential for wear there and potential for failure.
So you have to do that if you want to just replace the bearings if the bearings go bad?
Yes.
Oh, okay.
Yeah, it's a good amount of labor. Yeah. You know, these cars, as you probably all know, they're from a time where labor was pretty cheap. So, you know, you look at the maintenance schedule of the car and you know, if you had to pay for that kind of maintenance today from a dealer specified, you know, every service would be $3,000, you know, because you're working on your car for hours and lubricating and replacing and adjusting. And, you know, that's what's standard for these cars. So labor was high.
Is there a hex nut that you have to tighten that's down like in this area here that you have to go through the axle shaft to tighten? I seem to recall.
In order to get to, well, so this is held on to the differential housing with the nut that goes through there.
Okay.
But you can do that once this axle shaft is off.
Right, that's what I'm thinking
Yeah.
of.
Yeah, in order to get the slip joint off, because there's a hole in the universal joint in the middle.
Mhm.
So it's the only way you can get this to tighten this bolt that's here. And the only way to get this bolt out actually is to disassemble this joint.
I think I had a fear of losing my extension
Oh yeah,
in the tube.
that's a valid fear. Yeah. Yeah.
And what's that bolt tightening into?
So that bolt is tightening into the differential. So the differential housing. So there's splines here, and then it attaches into this gear. Yep, into the center of that. And then the shaft on the other side just goes into splines. So one on each side. So I think we've covered most of this.
So if I have a whining sound coming from the rear end, can I stick my head in the sand and ignore it, or am I just gonna? This is rather intimidating to see.
Depends if it's a passion.
So they can make noise for a really long time.
Mm-hmm.
You know, if they make more noise, then they really make a lot of noise. Then you really have to do something.
Okay.
But you know, I've had them in my own cars that make a lot of noise, and I've changed the oil.
Just
and,
turn up the radio.
well, after 5,000 or 10,000 miles, they make less noise
Yeah.
if you have fresh oil.
I mean, theoretically, if you kept it oiled, it shouldn't wear any more, unless it's like a catastrophic kind of.
Yeah, unless it's already worn to the point
Yeah.
there's damage occurring,
Yeah.
and you don't have races sitting together.
Yeah.
But yeah, if you have a little bit of noise, you know, in some cars, I've put AMSOIL severe gear oil in. It's pretty expensive. It's like I think it's $30 a quart now or something like that. But I had a car of my own that made some gear noise, and I said, well, let's put the good stuff in and see what happens. And after a few thousand miles, the noise got better
Okay.
rather than getting worse.
So is the cheap insurance thing to do when you bring your car in for servicing is to flush the differential oil out and replace
Yeah, absolutely.
it? Okay.
And most cars that come in for service, we check the oil.
Okay.
At the very least, you know, if you pull the fill plug and you just stick your finger in there, and if there's oil at a level you can reach, that's great.
Mm-hmm.
And then if the oil is reasonably clean, then that's really outstanding.
Okay.
But usually it's pretty foul. There's also the problem that when the car is up on the lift, you know, you have the axles are down low, but you actually have oil sitting here that's a little bit below what you would drain out. So you can't get it all out. So more frequent changes are not a terrible.
Okay.
It's not hard or expensive. So
Well, you check the oil, you check, was it hanging? Or do you make sure the axle is straight?
So I think
Fall under in your back, or how do you end up checking? the
in
oil?
theory, if we wanted to be 100% perfect, I guess you can say we would do it
It is
with the
correct.
axle level, but it's
It is correct.
we just do it up there.
Get
It's
a
not-
little more oil.
yeah, exactly. Yeah, as long as you're changing the oil and you have oil, you're way ahead of the game. So
On this differential, is it like the 108s where you have to do the gear lashing and painting it and
Yeah.
all of that?
so that's what we're going to show. Actually, we've done.
So that's the next step.
That's the next step. Yeah, and that's like the cloud of mystery of what goes on inside of a differential, and why nobody wants to go in there, which I think for good reasons.
And that contributes to some of that whining sound, whether it's cell or it's decel.
Correct. Absolutely. The way the
which
gears
my
fit together.
ponton has.
Yes, your ponton is
So I'm glad to see this because now
Yep.
it's coming.
exactly. Yeah. And in Greg's car, he has a really nice 190 sedan, and we put little microphones, for diagnostic purposes all over the car, and we drove around and we're trying to figure out where's the noise coming from. Which component? Is it really the rear axle? And I think what we concluded basically it's the rear axle, but it's not easy to figure out. It's especially when you have what is nearly a solid assembly here. Is it a wheel bearing? Is it a differential bearing? Is it the drive shaft? It's not so easy to figure out sometimes. And you hear very often, I had a customer this week with a later Mercedes, a 190E. And he told me that when he bought the car, it made noise. And the mechanic put a differential in it. And it still made noise, and it needed a wheel bearing. Needed a rear wheel bearing. But it's hard. It's not easy to figure this stuff out. And in the mechanic's defense, rear wheel bearings in those cars very, very rarely fail, but it's possible. So it's not always so easy to figure out where these problems lie. The good thing is that at least from let's say a preservation perspective, going this far in a car like this makes sense because it's all needed. It's never been done. All these bushings are old and all the bearings, it's going to benefit from this. It's not like we're working on a 5-year-old car where we're just throwing parts at it unnecessarily. It's all this rubber stuff, for the most part, we should change anyway. So it's worthwhile to go through and just do the whole job if you want to really solve the problem.
Are these the replacement shock absorbers?
Yeah, those are the built-in shocks. Those are the rear shocks. Yeah.
I assume you recommend just going with those and not any of the aftermarket stuff.
No, I don't think it's worth it. I think, there are some cars that I think Niemöller or even Mercedes supplies dampers for the original, because early cars didn't have gas shocks.
Right.
My Ponton came with dampers. We just put gas shocks and everything. They really seem to improve the ride. They seem to work well.
Back in the late 70s, I had Coney's put on my car.
Mhm.
It was such a stiff ride. We replaced it with just the original
Really?
spec.
Yeah.
Bilski.
Yeah. I don't know if Coney's are the best option for a lot of them. So I think if you tune them properly, perhaps, but it's not a straightforward thing. But and these shocks really are great. And that's true for all these Mercedes. For anything we work on, we generally putting these shocks in, really restores the original ride quality. So, and in some cases, we buy them from Mercedes, depending on the customer. You can buy these for, let's say, a Pagoda for a 280 SL, but if you buy them from Mercedes and spend 100% more, they come with like paint stripes on them and they look cool. So, and some customers, we do that for even cars of lower value. They want really genuine parts. So sometimes we do that. But yeah, these really.
How long did they last?
Quite a long time. I'm often shocked, no pun intended, by how good old shocks are. There seem to have been a generation of shocks that, especially in the 70s, that we take them out of cars and they're original and they're still good, but maybe they're a little softer. But I mean, like we've seen that many times where we take cars shocks out of SLs or 116 cars or whatever, and they're good.
Bill just said his is worth it all.
Wow. Let me turn this.
And you've seen I drive Ben and the my 126 and the Bill Stevens. So they get to blend. I don't think we need any booking, so sorry. Sorry for the noise.
But for a lot of those, our cars are sitting garage for quite some time, so the shocks are compressed.
Yeah.
Does that accelerate the wear and tear on them in the spring? Or?
Oh, they're designed to. Yeah. I mean, once in a while, if you see a shock fail, you'll see covered in oil, or you'll see oil leaking out of it, and that indicates the shock is actually failing. But it's not that common.
In most cases, if a Bilstein fails, what happens is the seal between the oil and the gas chambers go. Okay, and what it will do then is we'll go to full extension. And it'll be like riding around with a threaded rod for a shock absorber. And you'll know it. Yeah. And in most cases, very rare to see failures. Maybe you get a leaky seal every now and then, but very rare to get failures.
I think
we were Bilstein distributors for the whole time I was there. So
you see like 6.3s and 6.9s with air suspension or the hydrodynamic suspension. And those cars sometimes will sit with the suspension collapsed in storage or for long periods of time. And those shocks are completely compressed. And they sit that way for 6 months and they survive.
interesting.
Yeah, which seems like some kind of an endurance test for them. But I think it's far more challenging for them to actually operate in a car if you think of the violence that suspension sees just driving down the road. Much harder on the shock than it is just being compressed. Yeah. So, how you doing?
Hi there.
Hey, welcome. Any other questions? All right, let's move on to the great mystery of the differential. So I guess what's the big deal, right? Why is this so challenging? Why is this so hard? We'll show how these gears are supposed to fit together. So you've got this ring gear, which, kind of, let's say, sits this way in the car, and you have axles that go out to the wheels on either side. And then you've got this pinion that comes from the drive shaft. So the drive shaft attaches directly to this, so it comes from the transmission. And that sits inside this housing, kind of in this position. It's not in the middle, it's down here. And the reason it's down here, and I thought this was interesting that, I don't know, Bill, maybe you know why. I don't know. The distance off center is 1 inch. It's not metric. Oh, 1 inch. That's what the book says. It's 25.4 millimeters, but it says 1 inch, which suggests that there's maybe a patent on the hypoid gear design at the time. And there's a reason why it's not metric, because, you wouldn't expect the Germans to decide, well, let's make it 1 inch. That's seems like a good number.
Because the gear design was American to begin with.
Right.
And they just,
Yeah.
well, you start thinking about 0.4 of a millimeter, what the difference is.
Right, exactly. Yeah. So it's interesting. So the position here does two things compared to keeping it centered. First of all, it allows the teeth of each gear to have a little bit more surface area. So you have a little bit more bite. It's quieter running because of the design, and it allows the rear axle housing to be up further into the body because the drive shaft comes out lower on the housing, right? So it really improves the ability to design the car, and how the drivetrain fits into the body. So it changes center of gravity and all kinds of stuff. That's how this sits inside the car. It does not sit in the middle. It sits here. Now, the hard part of replacing these parts and making this work is setting the position of these gears and making sure that they mesh together properly, making sure they have the right amount of clearance. There's supposed to be clearance in the tenths or hundredths of a millimeter, but there's supposed to be clearance. And to make sure that they are stable and held properly inside the housing. So, the bearings are not too tight or too loose, so things can move around. So, go ahead.
If you have hundreds, THS,
Yeah.
hundreds.
Yeah.
I'm just thinking that could change just from temperature.
Yes. So, I mean, we assume that the engineers take this into account.
Okay.
Now, when they produce a gear set, they measure the clearances and they write them on the gear set. It's written right here. 0.20 millimeters. So that's the clearance between the gear sets that they measured during manufacturing.
Okay.
And there's enough variation in manufacturing that they individually measure each gear set and write on the gear set what the clearances should be. So it's not that they're all the same. Each gear set is different. Yeah.
And that number's gonna show up on that level right there.
Yes. So it's funny because the book says that it shows up here. In fact, it's shown in this photo right here. But in the new gear set, it was written on the bottom of the pinion. It wasn't written for the ring for whatever reason. So, but it is written there.
So this is a replacement part?
So these are the original parts, and what's in here now are replacement parts.
Ah.
They're new parts.
Okay.
Yep. Now, these numbers are really useful if you have the original tools, because you use those numbers to set pinion depth and set the clearance of the gears. And in theory, the way this should work is you put these parts into fixtures and you take measurements and you make calculations. And from there, you determine the number of shims that have to be put into place to position the pinion and how the position of the bearings on the side of the differential have to be set. And if you have all the tools and you do it all, it should be set up properly. Now, the book has a lot of little diagrams, excuse me, Paul, about how to do this. And they show this jig that you set up with the pinion and then you place into the housing and you make all this measurements. And it's really interesting because it's 2 pages of detailed information. And then it says, in order to check the accuracy of the adjustment, it's absolutely necessary to take wear pattern impressions on the flanks of the teeth. So what I'm going to show you is we're going to look at how these 2 gears interact with each other by putting paint on the surface of the teeth and then rotating the gears to see where they're actually touching, to make sure the measurements are correct. This is what Mercedes told you to do. But then it says, note, okay, if the adjusting device for the gear train is not available, the adjustment must be made by means of wear pattern impressions alone. Okay, this is the situation we're in. But adjusting by means of the wear pattern impression requires considerable expert knowledge and great experience. That's what it says right here. Yeah. Now, I don't consider myself to have great experience or considerable expert knowledge in this topic. I think, if you've built 50 or 100 of these, maybe you can claim that, but I certainly don't have it. I have patience. I think I have some kind of fundamental knowledge of mechanics and bearings and how things are supposed to fit. I can read instructions. And I think the result is pretty good. But it's certainly not, I think, as Mercedes originally intended.
So, in terms of painting, looking for wear and tear, similar to when maybe a dentist puts on filling or crown or something, and they give you the
Vitalium.
light and see where you got high and low spots.
Yes, that's similar.
So you take it apart, put it back together, take it apart, put it back together.
Yeah. This took me like 8 or 9 times.
Okay.
Yeah. Now,
Are your shims, where are your shims for the pinion?
so the shims for the pinion are here. Mercedes originally, no, they're not behind the bearing. Yeah. Yeah. Well, it's easy to change these because you just zip these 6 bolts out, and you can change the shims here. Mercedes provided these in like, I think between 1 and 2.4 millimeters in 1/10 of a millimeter increments. But they're solid shims, and none of them are available anymore.
So once you paint the gear and you find out where the wear points are, do you have to remove the paint?
I mean, before we assemble this, yeah.
Okay.
So before I do a final assembly, I'm going to clean everything again, and because it's been in and out a few times, and there's been, there's paint all over the gears. I think the paint in general is not damaging to the gear set. I don't think if I didn't remove it, I don't think it'd be a problem. It's just
I think if you read the tube, it says like it's soluble.
it's soluble in oil.
Yeah.
Yeah, that makes sense.
What was the rationale behind painting the interior red? You see that
So
multiple places.
that's a special paint. It's a Gliptol paint in Gliptol. You can still buy it. And it essentially seals castings. So the idea is that oil slides down easily on those surfaces, and it protects the castings. So you see very often people that incorrectly restore 190 SLs, I'm sorry if I'm offending anybody, they paint the engine red. It's not supposed to be red.
Yeah, you mean the inside or the outside?
Well, the outside.
The outside.
And what that red paint is, it was prepared as a protective coating, but the engines weren't red in the final finish. But very often the original paint wears off and you see the red, and then people restore the cars and they paint them red. So I think it's an indicator that someone did a restoration that doesn't know Mercedes.
And the oil itself as a lubricant wasn't enough for the casting that they needed. They felt it was necessary to protect it with this red coating paint.
Yeah, I think it's very common on engine building. I don't know enough about the metallurgy of the porousness of cast iron, but many manufacturers use that, not just Mercedes. Yeah, and even today, I think people build, building engines will yeah, exactly.
Does the clearance they described on the gear set, does that correlate directly to the number of shims you're using there, or is that totally different?
No, because every housing is different. So what they want you to do is set this up with a special jig that allows you, let's see. So I think it's this photo. It's hard to see, but this photo is actually this special tool sitting inside the differential housing. So it was a tool that would sit in here and give you a reference point from, let's say, the center of the axle shafts and measure the depth of the pinion. So it gave you a way to measure that accurately. And then you could set the number of shims from there, which would be a great tool to have. It would save a lot of time. But the process that I followed essentially was initially kind of guesstimating, let's say, how many shims we should start with. I've changed all the bearings. And if you measure the bearings, the new bearings are inside. But if you start doing things like, measuring the race, you find that, the new bearings are, 0.2 of a millimeter taller than the old bearings. And maybe that's just the height of the race, the way the bearing sits in is maybe different. But you start to try to realize there are all these minute differences in all these parts. And there's not enough standardization of the manufacturing. There's not enough formula that works. So you just have to start somewhere and then see where you're at and then take it apart and say, okay, the wear pattern is here. I need to move it this way and that way to achieve what I want. So let's make an adjustment. So there are shims here. To solve the problem of Mercedes not having shims available, I've had made shims cut. I've made them in 1/10 and 20th of a millimeter. So it allows me to essentially make any combination that I need. So we end up, I think there's 1.2 millimeters of shims in here, or 1.1 millimeters of shims in here right now. It's on the low side, which seems to be pretty good. In an ideal world, you end up with this, nice collection of all the original shims, and you can swap them in and out, but they just don't exist.
Do you have those made domestically or?
Yeah, they were made I think I just did the send cut send on these or something. I don't know. But I drew them on CAD and I just sent them to one of these guys. You send them the file and they, a week later they send you the shim. So, yeah. So, so that's how I'm able to dial this in. So you have this pinion depth, right? And then you have this other thing that you have to deal with, which is the position of this move this out of the way, of the differential inside the housing. And there are bearings on each side, as you can see. And
Jamie, before you move on,
yeah,
curious, how often does CAD come into play for this kind of restoration?
not very often.
Not very.
Yeah. It's, if we need to make something, I mean, I'm a very amateur CAD user. I think it's at a point where I ask my 14-year-old son to draw something. He does a much better job than I do. But yeah, once in a while we'll 3D print something, or usually for the more modern cars. But for something like this was pretty simple. To have parts made. I think someone in the club had these tools made, which you need for this, and this looks like something that was probably made by a similar manufacturer that was just laser cut and sent online.
We've
So-
done what, like 1,000 times in the entirety of.
Yeah, we had a tool made for the nut on the axle shaft because we didn't have the original tool. We had a tool made that allows us to use a torque wrench to torque the nut down properly. Which it's funny because in this book it just tells you tighten it very hard. That's the specification. But in later cars there's actually a torque specification for that, and it's a lot. I think it's I want to say it's like 180 Newton meters or something. Yeah, it's a lot.
It's very difficult to get 180 Newton meters on that.
For that nut. Yeah, and it's
on that axle
you
shaft.
need it's just got two little pins. It's really hard to tighten that up. It's really hard to hold the axle without damaging it to get 180 Newton meters on it actually. So, but yeah, that's something that we've had to make.
Somebody hold the top.
Yeah. So it's, like tools like that we can make. Those are simple tools. But to make this, without having original drawings and even having the original drawings, it would cost a fortune to make this tool. And it's maybe not worth it. Again, if we did 3 of these a month, maybe it would make sense. But there's not enough demand for it. So, anyway, so let's talk about how you achieve the correct position of the differential. So there's a bearing race that's pressed in to each side. There's one in here and there's one that looks the same on the other side, which I can show you here. Right. And actually we can see better on this side. So this bearing race is actually sitting against a plate in here that is threaded into the axle housing. So which means that by turning this, we can change the depth of that piece, which then sets the position of this race. So we can move the race in and out by turning this piece. Now in the book, they make it sound like you can just install all this and just put one of these tools in and turn it and make the adjustment. But in reality, at least these new bearings fit so tightly that it's impossible to turn that piece inside with those splines and effectively move the race. So every adjustment that has to be made, we either have to pull the race out with a puller, make an adjustment and then press it back in, or just make the adjustment. If we wanted to go in, we can turn this piece and then hammer it back in. So it's a lot of labor.
It's not that the race needs to sit flush there.
No, it does not need to sit flush.
Okay.
Yeah, it has to sit in the right position. Yeah. So the first time I put it together, I placed this on top and I didn't even bolt it down, and I could barely turn the pinion. So I knew already the gears were way off. And there's instructions about how to go through and do this, which side you start with. So we started with this side. I made quite a bit of adjustment. On this side, you can see the adjustment is much larger because the slip joint has to fit through here. And there's a locking pin or locking tab here that holds this ring into position. So there's nothing that holds this ring otherwise other than this locking tab. So if you remove the locking tab, you could actually, even at this point, probably turn this freely. So this can move in and out just the same as the other side. It's interesting, Mercedes sells this locking tab in, I think, 5 different varieties with this notch in 5 different places. So you can perfectly dial in exactly where you want that to be. One is available. And it's not this one. So we've got 2, I guess. But it's kind of impossible to make it absolutely perfect unless you have the collection of these tools, which, you know, I'm sure some people do, or someone did, but I don't at this point. So we have a few, I think, from that we've done, but you know, they really wanted you to dial this in absolutely perfectly. And in order to do that, you know, you need special equipment to measure the backlash between the gears, which I think is shown on another page here. Yeah, they show you measuring the backlash. So let's talk about backlash, what that means. So when we have this ring gear inside here, there should be some amount of clearance between the gears, right? And that's one of the numbers written on the ring gear. So in theory, you should be able to turn this a small amount, and this should not turn, right? Now, the amount of backlash you need, I think the example here is 0.16 millimeters, and that's measured at the edge of the ring gear. 0.16 millimeters of backlash at the edge, the outside of the ring gear. You can't feel this, okay? Now, in later differentials, they have a cover on the back. And it's pretty easy because you can assemble the whole differential, put it all together, and open this cover, and you can see what's going on in there, and you can set up, you know, dial indicators, and you can actually measure this. You can't do that in here. You need a special tool, again, which nobody has, or I don't have, to do this. But we can also do it by looking at the pattern on the gears, and you know, that's the game here, is setting these bearing clearances on each side, matching that with an appropriate pinion depth to get the correct wear pattern.
And that was all done using the paint trial and error method.
So I can demonstrate.
So the pinion depth that you then adjust to with the painting, like just
So it's not only the pinion depth, it's also the depth of both bearing races on each side. Yeah, so you have three adjustments. Yeah, exactly. So the one of the final tests, they have you measure the amount of torque that it takes to turn the inside race of the bearing with the assembly assembled. Okay, so originally there's a special pin wrench that goes into these 4 slots, and there's 4, and you're supposed to measure the torque. I think it's 50 Newton centimeters, between 50 and 80 Newton centimeters, I believe, which isn't much, right? That's really very little. So you're supposed to be able to measure that. There's a few problems with that. First, again, one has the tool. Oh, this is a tool we could probably make, right? This is not a very complicated tool. However, the new bearings that are supplied don't have the notches. So there's no way to measure it, right?
So where's your solution?
Well, this comes in a little bit of feel and experience to say, well, how hard is it to turn the race, right? If you can't turn it with let's say a brass punch or a pick, well, that's too tight.
That's a bit
right. And, you know, if there's play and it turns too easily, well, that's probably too loose. So, yeah, we have a little trial and error. Yeah.
And experience.
And experience. Yeah, exactly. Yeah. This is not the first one we've done here, and we've had good luck with it. But yeah, this is the great experience they talk about, I think. Yeah. I'm sure there's some guy out there that could just, you know, feel it right away and say, oh yeah, this is it. Perfect, you know, done. So I'll give you an idea of what this process looks like. So the process is, in order to do this trial and errors, we take fresh paint. I'm not going to repaint it here. And we drop this in, okay? So this now is sitting against the pinion. Take our axle shaft, right? Housing. We put this on top. We bolt this into place. And you'll see that this is not hugely labor intensive, but it's a process.
Is there a gasket that usually goes through this?
There's sealant.
Sealant.
So in the final assembly, all this surfaces have to be cleaned and then sealed. So then we we're making sure nothing's binding in the process here. Tighten this up a little more. Flip this down. And then we rotate. Now you want to put some amount of drag on the housing because you want to make sure that when you're turning the pinion, you're actually pressing against the thrust side of the ring gear, so it's not floating in there. So it's enough to kind of put pressure with your hand and turn this around. You spin it, right? And it's slightly noisy because there's no oil in it, but it feels smooth. So we go through the process. I usually turn it a little more than that, but we've got already marks on there. Take this apart. Here. This out. And then we look at our paint marks in the shadows here. So you guys can come a little bit closer. You can see the dark areas on the teeth of the gears. And it's centered in both directions. And it's pretty good.
So it's centered along the length of that.
So I'm quite happy with that actually, and how it fit. So, and we started out, we were touching out here, the first trial. Okay. Yeah.
And what is that gear and name called?
This is the ring gear.
Ring gear.
Yeah.
And these are your marks.
So this is just residual paint. I actually only painted these teeth. So what's left, what's on the outside here is just stuff that was kind of carried along by the pinion. But yeah, these are the marks that we're looking at. And you can actually look at the pinion too, and you can see that we're making impressions right in the center of the.
Right. So that's a good thing.
Yeah.
Which is your sweet spot, of course.
Exactly.
And that 0.16 on the outer edge.
Well, the backlash is determined, will also determine the position in this direction, okay, between the toe and the heel of the tooth, as they call it. It will determine the position. So you can actually check the backlash by doing this.
Okay.
Yeah. So without the information tools. So, and that's what they were saying in the book, essentially, that you can do it without the tools. It just takes some time and trial and error. Yeah. And from what I understand, I've never built an American diff, but you can see on this side. This is the power side here, the side in which during acceleration. From what I understand, American differentials are a lot easier to put together. I've never done one, but that's what I've been told. I don't know. And other cars are easier.
I don't know. It's very similar.
Is it? Yeah.
It's your pinion. Oftentimes your shims are behind the bearing,
Right. So you have to press it in and out.
which is
Yeah.
really ugly.
Yeah. To not
You
get
know,
used to
and sometimes you have a crush sleeve
yes,
that if you go too far,
that's how these are. The way
it doesn't work. But in order to get it to move, you have to use an absolute ton of force.
Right.
And then maybe it moves too far.
Yes.
And you start over.
Yeah.
I think they all just have their own little quirks.
Yeah.
You know, like this one, how you have to adjust those races just seems kind of ingenious if the races would fit properly in the
Right.
area.
You just slide them in and out.
You can slide them in and out.
Yeah,
You can
great.
make perfect adjustments. But
Yeah.
what you're saying is you got to pull those out,
Yeah. They fit so
turn it a little bit, put them back in.
Yeah. I don't pull them out completely. I just pull them out a little bit. Just to make clearance. Make the adjustment and then can
Crossing your fingers that it's going to work.
exactly.
Yeah.
I can see how those shims will adjust the preload between that bearing and that bearing. But I don't see how those shims there are going to move the face of the pinion in or out.
So
It seems like there needs to be shims behind this bearing in this end.
the way that
to do that.
the way that the pinion is suspended in the housing is different than later cars. Let's see. There's a photo here, but maybe I can also demonstrate with this. So you have this bearing. This is the bearing essentially that locates the pinion. And this bearing is sandwiched in between the housing or the top of the housing, this cover, and these nuts here. I can remove one and show you. So these bolts have a taper.
Okay, so that front parts, instead of putting a shim behind the bearing, they're going to move that
Right.
in or out to move that bearing. Okay, I was trying to figure out how you're going to move that pinion by only changing shims there, but that's
Correct. So this is the other side. So it doesn't actually interact with the bearing. It interacts with the plates.
Moving the bearing by riding that along the.
Exactly. So the bearing gets sandwiched
trying to
between.
put oil in that hole.
What's that?
We shouldn't be trying to fill the differential.
Yeah, don't take this out. Yeah, definitely don't take this out.
So that's what moves that front and back.
That's what moves that front.
Yeah,
Exactly. Yeah, it's very
What
interesting.
moves the back.
So-
The other one will move the front.
So every time you change the shims, you have to loosen these, tighten up the front, and then you put it together. And this is a 25 Newton meters. So, and then you torque this down, and that gives it the proper amount of pressure. Almost. There. So that's what positions the pinion, what holds the pinion in place. And then you lock that with this locking nut.
So this has a roller bearing. None of those bearings are tapered.
No, that's what's interesting about it.
So there's no preload on that at all.
No preload at all. So this is a race that is pressed in, held in by two circlips.
That's
Inside here. Yep. So the later cars with the crush sleeve, they do have taper bearings.
Starting when?
These cars have it. So in 60, yeah, or 59 and 111. Yep. Do you feel how beautiful the bearings here?
Yeah, it seems like it's awful loose, but yet there is no preload, so that would be why it's loose.
And this flange is also, there's no seal in here right now.
Right.
And then this flange is loose. It's not bolted in place. So there actually is a tiny bit of play between the.
Yeah, I see what
Yeah, but if you feel it, you're feeling the play between the flange and the shaft at the moment. But that gets bolted down with this nut. It's quite interesting. Yeah.
It's interesting to take it apart, put it back together, see how it works.
Yes.
Then the part behind that is someone had to come up with all of this.
Yes.
Say, how do I make this do what I want it to do?
Right. Yeah.
That's pretty cool.
Well, I think that's part of the joy of owning these cars.
Yeah.
Is to look and say, boy, these guys were really smart.
They were on their game.
And there were no computers. They had these guys and drafting tables and slide rulers and figuring all this stuff out. And they made products that were really exceptional, exceptional quality, long life, and outstanding performance. So I think that's why so many of us own these cars, because we appreciate it. Yeah. That's why you see a lot of engineers and doctors and technical people would buy these cars new, and I think still collect these cars today. That's I think the general public often looks at these cars as status symbols or something, and they to the owners they're not. Their
right.
appreciation of mechanical designs.
The engineering.
But the idea behind the ring and pinion, it's over 100 years old,
Yeah.
and it's still used today.
Right.
Like the same basic design, it's in 2026 model year vehicles.
Yeah.
It's amazing that something like that has never really been.
I wonder who the inventor is. Is it like Kettering or one of those? Guys like that came up with so many things that we take for granted today. I don't know who the inventor was of this basic design of the differential, but it's clever.
I think it was sometime out right after
I see that.
1919 or
I
something.
can see that one.
Oh, really?
What's that?
But it's just amazing that
That noises.
that ring and pinion
I was
is
looking.
still used.
Yeah.
The same.
Yeah. There's no improvement.
There's no improvement. There's
Yeah,
been no
basic
improvement.
design. Yeah.
The basic design, right?
I think before that, some cars had one wheel that went out, right?
Yeah.
Yeah.
It's almost like there's a.
Yeah, you can see wear in the.
Yeah, it's a. That's. Wow.
And maybe that was the noise. You know, I can't read the gears enough to tell you if that was the noise, but that could certainly have been.
If you look in there, you see it's almost like a little dip. Exactly.
Yeah.
And it's consistent throughout. And it's right along in that.
Not where you'd want to have the pattern like you have it there. Yeah, that's
Right.
And that's not in the center.
They tell
correct.
you if you're
Which is where it ought to be.
going to reuse a ring and pinion.
But it's consistent
you-
all the way
Making
around.
changes,
So
let's say change a bearing.
that little
you
dip
have to
or
take
divot.
the pattern and then match the pattern when you reassemble it. You can't make the pattern.
you follow
perfect
what I
because
mean?
The gears are already
Get a
worn in
picture.
together.
let me put it down so it doesn't move. That's kind of.
So what's this tool used for when you set it up?
This tool is actually would be how we would measure the drag in the bearing, for example. So this is just a simple beam torque wrench.
Okay.
But it has a lot of applications in these cars and their differentials, especially like in the cars with the crushed sleeves. You have to achieve a certain amount of drag or preload in the bearing, and that's what this tool is used to.
So that goes on
Oh,
to.
This tool.
Yeah.
This tool goes onto the nut that goes onto the pinion.
I get it. Okay.
Yeah. So that goes here.
Got it.
Yep.
So what is the, where is that tool used?
So this tool is used to move the races in and out inside here. So this tool fits in here.
And it has a spot for that tab that so it doesn't catch.
The tab you remove so you
Okay.
can turn this,
Okay.
and then this will seat down into there, and you can turn it.
And the club offers that and the little one, right? To
Yes.
separate the those.
Oh, I don't know. Not anymore.
They used to.
I would say if you didn't have these, you could work around. You could make just even a simple something to go across, or even just a punch. This actually was almost, once the race was out, it was like finger tight. The other side was a little harder to move, but yeah. What they tell you to do in the book is to assemble all this and turn the outer one. And you're supposed to use a long extension and then, get this to engage in that through this way without going too far. I don't know what the original tool looked like, but if you were to do that, I think we were thinking about actually welding something on the outside. So if you engaged it, it wouldn't go through. Because, trying to do that through here, it's very easy to overshoot, and it's machined perhaps a little too tight, and it's hard to get it in place. So
See, talking about you were saying earlier about these cars getting proper service in the 50s.
Yeah.
I mean, just imagine, shops didn't have, ratchet sets with, 3-foot extensions.
right, yeah, right.
And then to have that special tool,
Right.
it's no wonder that, and these are all metric and, you're in America. So good luck.
I would think that if the customer was important enough or complained enough, they just sent a whole new axle from Germany, and that was it. You got a whole new assembly, and you put it in the car. That was it. Or they flew the guy from Germany to come. Yeah. Which was a thing. Especially for 300 SLs, there were guys that were doing that, flying all over the country and fixing cars.
But do they come with the tools?
That's a good question. So one of these guys is still around, and he's been coming to our Mercedes-Benz Club events. Carl Friedrich, and he's 95, and he has all kinds of interesting stories of coming in the 50s and working on 300 SLs, and he spent time in Puerto Rico working on cars and all the challenges he had with the climate there and hot running and so on. Next time I see him, I should ask him, did you just fly with your tools, or what did you have? So I don't know. It's a good question. But it must have been a lot of luggage if he did, because it would be heavy stuff, Yeah.
So Jamie, to replace the rubber axle boot, you have to just remove the right side of the axle?
Yes. Yeah. So if you really try hard enough and you're really, I don't know, looking for trouble, you can do it in the car. I know people who have done it. But I don't think it's a good idea because I don't think you can adequately feel if the shimming is correct. And I think it's very hard to get it back together properly.
Right.
I think you can slap it together if you wanted to.
Okay.
But the right thing to do is take the rear axle out. And you don't have to disassemble the differential.
Not the whole thing, just the right side.
Well, no, take the entire assembly out and then set it on the bench and then take the right side off. That's what we do.
I see.
Because again, usually we end up reshimming things because of wear and replacing some of the bushings, and it makes the car tighter.
Okay.
So it's a worthwhile activity. And the other alternative is to put split boot in. Mercedes sells a split boot. Still sell it. And they still sell these special little
But
brass
that's what really
staples.
tends to leak more than obviously the.
Yeah, they all leak.
Yeah.
Yeah. It even says in the book it's going to leak. When the instructions on installing it tell you
Right.
it's going to leak.
Okay.
So,
That,
They don't
Yeah.
have to be
that's
bad.
another special tool, a stapler for the split boot.
right. And we have that tool.
All right.
But
Yeah.
I'll say this, I have done a split boot in an SL 190, and I wouldn't even consider doing it without taking the axle out.
Really?
Because there's nowhere to fit the tool between the body and the gas tank.
But if you go to the trouble then of removing the entire axle, why go with a split boot when this is going to be?
Well, because then to do the solid boot, you have to do the whole pin.
Right.
And all the shims, and all the seals.
right.
Yeah,
And
this
if
could add a
it's
couple
all
more.
good. That's a lot of, that's hours of extra work.
Gotcha.
But if you want to do the axle seals and the split boot, if that's where your problems are, just drop the axle.
You might as well just do it completely.
Okay.
For what it's worth.
It's still a 10 or 12 hour but it's not
Still
that
good?
difficult to take the axle. It's not,
It's obviously
it's not hard to do.
Oh, that's great.
Okay.
This car has split boots in it, which I thought was interesting. This 300 has split boots in it, and they're seeping a little bit, but the car had no oil in the rear differential when we got it. We put oil in it; it's still in there. So,
But that's the Volkswagen style split boot. Those are bolted together.
yes, that's true. Yeah, they're
Those
not
are
stapled
stapled.
together. Yeah,
The other thing I believe Mercedes wants to split it in half.
yeah, they want it in the middle because you can't rotate the boot because it's not round.
I'm
It's
pretty sure.
taller.
I'm pretty sure because I obviously did mine without manual.
Yeah.
I'm pretty sure mine top.
Oh, really?
I learned how to put oil when I bought.
I think it's here. Look, it says Oben.
Right.
Top.
I don't think mine is.
So it's supposed to go
positioned-
this way.
I don't
Yeah.
think mine's
Yeah.
positioned that way.
Yeah, I've seen them also with the seam at the top, and they seem to work.
It seems to be.
But
okay.
yeah,
the
it's
thing that
supposed-
surprises me is I would have put it in the mid 70s.
Yeah,
And the car was 15 years old.
right.
It's now been on since 75, 76.
Yeah.
And it's still, I go and check it, poke it. It still seems like it's not robbing us.
It
I'm not
makes
sure why the first one would last 15, the second one would last 50.
yeah, right.
It seems odd.
There's this idea that, and I think this is valid, that the rubber then was probably very different than the rubber today.
I want to replace the radiators in the 60s all the time.
Yeah.
Right.
I was like, "Shit, I've doing that for 20 years and they're still good."
You'd be amazed how many Pagodas we get with original hoses on it still.
Yeah,
Usually
like-
radiator hoses are not, but
You find things like that, they're all apart right away.
yeah,
It's weird.
Yeah.
Were the original radiator hoses red?
no, those are American. Interesting. Yeah. Yeah. And auto parts stores. Yeah. Yeah. So,
Well, thank you.
I guess this concludes our formal discussion.
Thank you very much.
Thank you very much. I hope it was useful. At first, I was worried. I was like, "Am I going to have enough stuff to talk about?" But I guess we did okay. Now, feel free to look at these cars. Watch your head. The lifts are low. But you can take a look at this arrangement, which is fairly similar. This is the same as the Pagoda. They added this spring at the top for handling purposes. Built the factory more about why. But this is the same loop. Actually, a lot of the parts are the same. Wheel bearings are the same. There's a lot of interchangeable parts between this later design. This is the 1970s and what was used in the 1950s. And this design stopped in 72 or early 73. There was no more cars with this swing axle design. Starting in 68, some cars had what they call the diagonal swing axle, which was kind common up until the early 90s. And Mercedes used that design for quite a long time, which was really successful.
116, you mean?
116, 114, 115, 107, 123, 126. All those cars used not only the same design, the same components. The trailing arms are interchangeable and they're very, very similar components. Small cars and large cars.
And how does the diagonal swing differ from this swing?
It's a totally different design. So the differential is a small self-contained unit with
little thing.
external
Yeah.
action straps.
Okay.
Well, geometry better than travel.
Does hold geometry better, and also part of that came about from the whole Corvair thing in the early '60s,
Right.
with the spring axle with rear engines like in Beetles,
Right.
and the jacking under extreme look, if you raise the rear end, it jacks and the car jumps sideways.
Right.
So what they did, Volkswagen, Porsche, and Mercedes, they designed to use the transaxle or the differential to be in the center, and they came up with CV joints to run the axle. So you had this movement
Better.
Right.
And one guy moving like this.
No, both of them.
No, but on
Instead of one.
but
instead
on
of just one,
instead of one moving, the other's fixed.
or on a Volkswagen or a 356, they were both axles worked like the right side.
Oh, really?
Yes, and then one of the problems there, and also with the Corvair, is when you go into a corner.
Yeah.
And with the rear engine and the back end gets light, it lifts.
Yes.
And then you spin. So what you do in most cases there is, if you know it, keep your foot in.
Yeah, you have to keep and power your turns.
You're better off.
Keep the power on
Feel
and the
back end
turn.
coming
Yeah.
up.
Power into it, they would say.
For autocross, the SCCA won't let you run a swing axle Beetle unless you have a camper compensator in it because it can jack and roll.
Really?
Yeah.
So I didn't know that. So the Porsche doing this way was not
356.
really
356s were a little more controlled, yes. But they still did it.
interesting.
Even early 911s like mine do. I mean, you get my car moving right. It'll.
Interesting.
The later diagonal.
Well, Jamie, thank you. It was great. Great. I learned a lot. Good. Thank you.
Like this, is it unloads, right?
I know what's coming.
It's a camera. when the back end comes up.
What's funny is why would you
Positive.
not only to put a tag on the undercarriage of the car is interesting, but right there is where they chose to put it. I thought that was really strange.
What tag are you?
It's like a trunk repair tag on the compensation. I don't understand. Yeah. And I like it because it's a very survivor-ish car. It's never had restoration work. It's got leather. It's a pretty nice car, actually. It runs really well. We got it running already. It really runs great.
The valve cover off. It had a new cam and new timing chain.
Yeah, someone did a lot of work on this car, so.
Can you talk about the rear end in this one?
Sure. Bill can talk more about it. But totally different design.
Yes, it is. It is, both arms swing. These use the same type of joint as the inside of the 190.
Okay.
The right side inner joint.
Yeah, there's like a universal joint.
Right.
Yeah.
The difference is in both sides. Now this also has a adjustable rear suspension. These relays and this motor,
Adjustable rear for rear height control.
for height control. So you can turn the knob on the dashboard if you've got it loaded. And according to the owner's manual, you're only supposed to do it when the car's loaded.
Right.
And what it does is it raises the back end.
Just the back end?
Just the back end.
Yeah.
Yes.
We've never
This is
seen it work.
1953.
We haven't seen it work yet. No.
Yes.
It doesn't, or you have a truck.
Well, it doesn't work. We have to figure out why.
Well, you gotta load it.
I guess we have to load it first, but we can't even try it otherwise.
Until it's
Oh,
loaded.
no, it should move.
It should do something.
Yes, but we haven't tried it.
No.
I know it does not work in the converter, but then the components are not in great shape.
And it's different in the Pagoda as another generation of rear end.
The 190 only it has the compensator,
Yeah.
which helps with handling and that it doesn't squat as much under acceleration.
But
And then this is the same as, this is going close to the 1.9. This is the same as the 1.9, but the axle boot is up here. Is this a solid or a split?
That's a solid.
It is, okay. That's a solid. Yeah, so you can sort of see the connector here to the chassis.
This one's clean underneath too.
Yeah.
Well, this is, I've been putting this together for 2 years.
Oh my.
That's the top of the bulbs, brake marks, and fuel lines.
Yes. Everything in this car is either painted or new. Or refinished or whatever.
Is this Jamie's car, your car, or?
That's a customer's car.
Customer? Okay.
It came back from paint with nothing in it but the rear wiring arms.
Wow.
The only thing that wasn't rebuilt was the transmission.
You guys think?
Okay, new. Brand new. And the front end of this is the same as the 190. It's identical. You could unbolt this subframe and bolt it right into on 190.
So it's still exhaustive way to go.
Except it's new.
And it's a 6-cylinder.
Oh, is this a 219 or 220?
That was a 220.
220. Okay.
Where's the steering box here? Back here?
Yeah, it's up here. Right there.
Okay.
See it?
Yeah.
Right next to the dipstick.
So do you have to drop the front end completely to get access to it?
I don't know. I haven't tried that yet.
Okay.
Because this wall went, this went in. We put the motor on the subframe and we lowered the body onto it
Okay.
because that's the recommended way to do it.